Welcome to a very quick review of sigma notation or summation notation. Just 4 quick examples here just to get the essential skills covered. Example 1, write the sum 1 plus 2 plus 3 plus ... plus 10 in sigma notation. So sigma notation was invented for sums that follow a pattern, which happens all the time in math. So what I'm going to do is put an index I in here and say we're adding up all these i's as I goes from 1 to 10. So what the sigma notation does is you sub in the smallest value of I, and then you step up to the next integer I, which is 2, and add that. And you step up to the next integer I, which is 3, and add that, and so on until you get to this terminating value at the top of the sigma. So that's how you do it. Example 2, expand the sum as I goes from 1 to 5 of I squared. So we're going to sub in the smallest value and we get 1 squared, and then we add to that what we get when we sub in the next integer. So 2 squared, 3 squared, 4 squared, and 5 squared, and it comes out to 55. The next one is just to illustrate that you might have a really complicated function inside of the sigma notation, but I'm still just subbing in I equals 1, 2, 3, and so on. So this one gives me the sine of 1 pi over 2 plus the sine of 2 pi over 2. And really what we're doing here is taking a trip around the unit circle in increments of pi over 2 and evaluating the sine function starting at pi over 2 or 90 degrees. So I get 1 out of that first term. Second term is the sine of pi, which is 0. Third term is the sine of 3 pi over 2, which is negative 1. And then back to 0 by the time I hit this term, because that's the sine of 2 pi. And we've completed a trip around the unit circle, and then I'll just do it again, and I can see that everything cancels out, and I get 0 for that one. Finally, and this is a really important skill when we're approximating integrals with Riemann sums and trapezoid sums, you need to be able to use a computer algebra system, or at the very least a TI-84 or equivalent calculator to compute sums. So I have the sum as I goes from 1 to 100 e to the negative I squared. And what I'm hoping for here is a decimal approximation. And I'm going to use a computer algebra system for this. So I'm using wxMaxima. The sum command is how you do sigma notation in Maxima. And then I put in this function. %e is the special symbol for e to the negative I squared as I goes from 1 to 100. Putting float out in front gives me a decimal approximation, and I hit Shift Enter, and I get 0.386. Let's take a look at the TI-84. To get to the sum function, you have to hit the math button and then 0. And it looks like that on this particular calculator. There are a few different variants of this, and I'll try to show 2 of them. And so I have the sum, and I'm going to put the function in here that I'm interested in. So e to the negative, and then I'll hit the variable key, so x squared, comma, as x goes from 1 to 100. So we're just using x's instead of i's. Parentheses, hit the enter key, and I get the same approximation, 0.386. Now, if your settings are different in your TI, this might look a little different. This is what it looks like with the math print setting on. So I'm going to, again, use x as my index, and I'm going to go from x equals 1 to 100. E to the negative x squared, and hit enter, and I get the same approximation, 0.386. Now on TI-83s, there's an even older syntax, and you may have to look it up if you have a TI-83. It's not too hard to find the information on the internet if you have an older calculator.